Welcome to LabMinutes.com and our lab video series on IPv6 on Cisco router. You can find a complete list of IPv6 video on our website by clicking on the link above and sign up for our newsletters to receive the latest video updates. In this video, we will look at how we can transport IPv6 traffic across IPv4 network using 6-to-4 point-to-multipoint tunnel. For our lab topology, we have three routers, R1, R2, and R3, each with its own IPv6 network. In the middle, we have an IPv4 network with EIGRP enabled to provide reachability among their loopback 0 interfaces. The goal for this lab is to provide reachability or connectivity between these IPv6 network islands using the 6-to-4 tunnels. We also have a Wireshark machine that's looking at R3 interface so we can analyze the encapsulated packet later on. So let's first try to understand the concept behind the 6-to-4 tunnel. So in order for us to use the 6-to-4 tunnel, the subnet of the IPv6 network has to be in certain format. And the format is shown right here, starting off with the prefix of 2002, and then followed by the IPv4 tunnel destination. So this will be the source interface address of the local dual stack router that terminates the 6-to-4 tunnel, and then followed by a 16-bit subnet ID, which you can use to allocate or partition your local subnet. And you can see all of these together are combined and make up of the first 64 bits of the IPv6 address. So by having the IPv4 tunnel address kind of embedded as part of the IP prefix, then this is for the router to quickly look up and find out what destination IPs of the traffic would be. So that way the router doesn't need to have the destination IP hard-coded like we saw on the point-to-point tunnel configuration. And obviously by having this predefined subnet format, you no longer have the freedom to choose your own IP address for your IPv6 network. So just to give you an example with R1, that's going to be sourcing from its loopback 0, 172.16.0.1. We're going to need to have our local IPv6 network to follow this particular format with 2002, and then the local router tunnel IP, which is AC 10, and that corresponds to 172.16, and then 01 for the 01. And then you can just pretty much pick any subnet IDs you want for those networks. So let's now go to task number 1 with the 6-to-4 tunnel. First, we need to create a loopback 4 on R1, 2, and 3 with the IP subnet that are in compliant as required by 6-to-4 tunnel. Then we need to configure the 6-to-4 tunnel on the three routers with the IP address of the tunnel interface being configured using the general prefix command and the tunnel interface to be sourced from loopback 0. And then we need to configure static routes to provide reachabilities among their routers loopback 4. And the static route that we need to configure has to support future IPv6 sites without additional routing configuration. And we need to verify reachability between their loopback 4, and at the end we need to review Wireshark packet capture for the encapsulated packets. Okay, so first let's get on to router number 1. And just to verify the reachability from R1 to all of the R2 and R3 loopback interface, since we have the EIGRP enabled, so we can do show IP route EIGRP, and here we can see R2 and R3 loopback 0 IP listed in the routing table, and we can try to ping those as well just to make sure. Okay, here we can see we have reachability to R2 and R3 loopback 0 from R1 loopback 0. So now let's configure loopback 4 on R1 with the IPv6 address. And for our prefix, we're going to have to follow the exact same format as we talked about, 2002. And then the tunnel source IP on R1, in this case, is AC 10.1. And then for the subnet ID, we're just going to leave it at 0 for all the three sites, just to keep it simple. So the address in this case would be 2002. AC 10.1 and ends with 1 for the last number for the IP /64. And now to get ready to configure the tunnel interface, we need to use the general prefix as specified by our task. So let's see, exit IPv6 general prefix, and this is nothing but a template that you can use to configure your IPv6 addresses. For the command IPv6 general prefix, first we need to give it a prefix name. Here we're going to call it 6-to-4 prefix and a question mark. And normally you would define a regular IPv6 prefix, but since we're dealing with a special case here with the 624 tunnel, as you can see, we have an option just for that. So here we specify 624, and then we need to also specify exactly which tunnel interface that we'll be using this on. In our case, just pick tunnel 1 and then enter. And now we can start our configuration for our tunnel 1 with the IPv6 address for the tunnel IPs. With the question mark here, instead of hard coding the IP, we're going to refer it back to our general prefix, which is 624 prefix. And then for the remaining part of the IPs, it can be pretty much anything. Just to keep it simple, we're just going to do :/128. Okay, and then for the tunnel source, we said we have to source from loopback 0. Again, that IP that has to line up with the IPv6 format that we just used or created on our loopback 4. And then the last command we need is the tunnel mode, and that would be IPv6 IP. So just IPv6 running on top of IPv4, and we are using type 624 tunnel. Okay, now we need to configure a static routes. And the task specified that this static route needs to support pretty much all the IPv6 sites that use 624 tunnels. So if you look at the format, we know that all the sites are going to have to start with 2002 and then followed by whatever the tunnel source IP is going to be. So for our route to cover all those space, just IPv6 route 2002, and that is 16 bits, so /16, pointing out tunnel 1. Okay, and then to get ready for our ping test, we do debug IPv6 ICMP. And that's all that we need. So let's repeat those configuration on R2 with loopback 4, IPv6 address for R2 starts with 2002, sourcing from loopback 0, that would be 172.16, which is AC10 again, 02, so 2, 1/64, then exit IPv6 general prefix 624, again prefix as the name, 624 tunnel 1, then get enter tunnel 1 IPv6 address, just copy and paste, :/128, tunnel source loopback 0, tunnel mode IPv6 IP 624. Okay, and then IPv6 route 2002/16 tunnel 1. And debug IPv6 ICMP. Now the last router, router 3. You see the command is pretty much identical on all of them except for the IP address of the loopback 4, which needs to strictly follow the predefined format. So for loopback 4 and R3, it will be IPv6 address 2002 AC 10. This time it's 3 because loopbacks of R3 ends with 3 for loopback 0. Then 1/64. Then IPv6 general prefix 624 prefix 624 tunnel 1. Okay, get into tunnel 1 IPv6 address, copy and paste, :/128, tunnel source loopback 0, tunnel mode IPv6 IP 624. IPv6 route 2002/16 tunnel 1. Okay, and then debug IPv6 ICMP. So now that we have all the debugs enabled on off the 3 router, let's go ahead and bring up Wireshark, open Wireshark, start capturing packet on the interface, and then on R3, we're first going to try to ping R1 loopback 4, which is 2002 AC 10 11 So I just want to point out, when you look back at IPv6 routes, it doesn't really show the destination IPs as part of a static route command at all. All it says is just push it out through tunnel 1. And that's because, as we discussed, the router automatically figured out the destination tunnel IPs based on the embedded IP as part of IPv6 address prefix format. So here for R3 to ping R1 is 2002 AC1011, sourcing from loopback 4. See, those are pingable. And trying to ping R2 loopback 4, we just need to change the IP address right here from 1 to 2. And you can see those are pingable as well. So let's take a look at our packet capture. First, let's look at our first batch of pings from R3 to R1. See if we can find those. Scroll down right here. Sourcing from 2002 AC10-3, so we know it's coming from R3 going towards 2002 AC10-1. And you can see how those embedded IP gets translated to the IPv4 source and destination IP right here. So AC10-3 in hex becomes the 172.16.03 in decimal. Same with the destination IP, AC10-1 becomes 172.16.01 as far as the tunnel destination on the IPv4 header. Okay, and right after that, since we're doing IPv6 IP, we have a IPv6 header stack on top of v4, and that is the actual source and destination IP address. And then we just have the ICMP v6 ping request. Same thing with the reply. It's just everything gets reversed as far as source becomes destination and destination becomes source. This time it's coming from 172.16.01 going back towards 172.16.03. Okay, scroll down a little further, which is our second batch of pings. Same thing happened when we ping from R3 to R2 loopback 4. So now with the embedded AC10-2, the IPv4 tunnel destination becomes 172.16.02. So you can see with a single tunnel interface, R3 is able to reach both R1 and R2, so it's essentially a point-to-multipoint type of tunnel. So let's try to do the ping from R1 and R2. So first with R1, ping 2002 AC10, ping R2, so it's 2, 1 sourcing from loopback 4. So you can see R1 can ping directly to R2 as well. And obviously R1 should be able to ping R3 since we just verified that from R3. And just to complete our ping test, we're just going to do the exact same thing from R2 with 2002 AC10. First ping R1, 1 sourcing from loopback 4, and then also ping back to R3. Okay, so you can see all three routers are able to ping each other loopback 4. So let's go back and make sure we have met all the task requirement with verify reachability. So we just do that, and we also review the Wireshark packet capture as well. So you can see the concept for 6-to-4 tunnel is pretty straightforward, and the configuration is fairly simple as well. But the main limitation is you can see that you need to strictly follow the IPv6 address format, and this may or may not work out for you, especially if you already have an existing IPv6 network that does not line up with those IP schemes. That might require you to re-IP. But if you are dealing with a fresh new install or a greenfield implementation, then 6-to-4 tunnel might be one of the options for you. So that wraps up our video on IPv6 6-to-4 tunnel. You can visit our website to view an extensive list of our lab videos and sign up to get access to additional lab contents. Thank you for watching LabMinutes.com, and I'll see you guys in the next video.